Hi, Professor Vern. So, what are you working on today? And thanks for the cool NASA pencil you sent me.
You're welcome, Administrator. I'm testing a device that can reduce objects to 1/12 size to save on shipping and storage. See here what happens when I point the device at this laser pistol.
Wow, that's wild. But I'm not going to ask what we need laser pistols for.
Administrator, check out Robot's Robo-Solar Cycle.
Born to be wild.
That's amazing. In fact, I want to discuss how MTA uses solar energy.
Excellent. Now, solar energy is harnessed by solar panels that are made up of solar cells. Each cell generates about a half a volt when struck by light photons. The larger the solar panel, the more solar cells, and the greater the output voltage. Now, in typical installations, solar panels are combined together to achieve the energy level required by whatever we need to power.
So, what are they made from, Professor Vern?
Solar cells, also known as photovoltaic materials, are made of silicon, the same material used to make transistors, integrated circuits, microprocessors, and, well, robot.
I'm not just a pile of transistors.
Settle down, robot, you egotistical extended memory. Now, as I was saying, I have a mock-up to demonstrate the basic parts of a solar system.
Let's see it.
Administrator, see here the basic parts of a solar energy system, including a solar panel and an inverter.
So, what's the inverter do?
Great question, Administrator. Solar panels produce DC voltage, so the inverter is needed to change the DC into AC voltage, which is needed by most things we want to power, like a house. Now, I will demonstrate that when I shine a bright light on the solar panel, that it produces electricity that powers my flight control panel. I'm going to use the glowing fuel rods from my mini nuclear generator as our bright light source.
Hey, didn't that thing almost melt down the last time you used it?
Oh, it's fine now, I think. Activating glowing fuel rods. Flight control panel has solar power.
So that's great, but when the sun goes down, aren't we left without power?
Ah, great point, Administrator. There are times when we need the solar system to work at night, such as when lighting a bus shelter. If we add a battery and a charging regulator to our solar system, then the battery will be charged during periods of sunlight, and then it will provide power at nighttime or when it's cloudy. I'll demonstrate how this works. See here that I've now added a battery and a charge regulator to our solar system. Now I'll simulate nighttime by turning off our bright light source to see that our flight control panel still is powered. I'm now going to turn off the bright light source and see that our flight control panel still has power supplied by the battery.
That's cool. So what does the regulator do?
It's similar to the voltage regulator in your car. It controls the charge that's applied to the battery so the battery doesn't get overcharged.
Professor Vern, where do we use solar panels at MTA?
MTA has an array of thin film solar panels on the Northwest Bus Maintenance Facility. And they generate over 500,000 watts of energy and have saved MTA over $800,000 in energy costs.
That's awesome. So what are thin film solar panels?
Thin film solar panels are thin layers of photovoltaic material that are deposited on lightweight materials such as plastic. Now, traditional solar panels use glass, which would be much too heavy for the Northwest Bus application. See here, I have a sample of a thin film solar panel.
That's excellent. I seem to have lost my NASA pencil, but Anyway, are we using solar panels to power anything else?
In fact, we are installing solar-powered bus shelters. And I think you would enjoy a tour to see a solar-powered bus shelter.
I most certainly would.
10-4, Administrator. Hey, would you like me to shrink anything down in your office?
No thanks. I'm still looking for my pencil. Just message me when you're there.
Administrator, I've asked Deputy Director of Facilities and Support Services, Mark Burkhart, to show us a solar-powered shelter.
Hi, Mark. How are you today?
I'm doing great, Mr. Quinn.
Robot was supposed to join us here. Here he comes now.
What the? Robot? Anyway, Mark, where are the solar panels?
And the solar panels are located up on the roof, which provide power to light up the shelter at night.
Very cool, Mark. So how many of these solar shelters are we installing?
We're installing dozens of these throughout our service area.
Wow, that's awesome. Thanks so much for showing me this.
Professor Vern, your machine shrunk me. I order you to restore me to normal immediately.
That'll take a while, Administrator. I haven't got the enlarging part working yet.
I'm not gonna forget this, Professor Vern. Well, at least I found my pencil.